Section 3.2, graphing equations in two variables. Some definitions that you need to know. The x-intercept is the point at which the graph crosses the x-axis. X-intercept crosses the x-axis. Y-intercept, the point at which the graph crosses the y-axis. Y-intercept crosses the y-axis. And just a vertical line is an equation of the form x equals any real number. And just to refresh your memory, any vertical line, when you graph it, goes up and down, and a horizontal line is an equation of the form y equals a real number, and it goes from left to right. Let's move on to the next slide. So here's one. It says graph each linear equation using the point plotting method. So here's the linear equation you're going to be working with, y equals negative 2x minus 1. So basically what we're going to be doing is we're going to be using the a t-table. You're going to provide the x values, and hence I'm using negative 2, negative 1, 0, 1, 2, because those are easy values to work with. And then what I'm going to have to do is find the y values that correspond to each of those x values. So it's going to look very similar to what you did on the previous section, 3.1. So you're going to plug in the x value for the x value, you're going to plug in negative 2 into your linear equation. You're going to simplify. In this case, we get 3. So the y value that corresponds to this x value is right here. Then I'm going to do the same thing for when x is equal to negative 1. Negative 2 times negative 1 is positive 2. Take away 1 is equal to 1. When x is equal to 0, I plug in x equals 0 into my x value here. And I simplify, I get negative 1. Same thing when x equals 1. Notice that I get negative 3. And then when x is equal to 2, I get negative 4 minus 1, which is equal to, if you do the adding integers, changing the subtraction to addition, you end up with negative 5. Once I have these ordered pairs, like for instance negative 2, 3, I go ahead and graph it. And this is where negative 2, 3 is. Then the next one is negative 1, 1. Here it is, 0, negative 1, which is right here. And as you can see, I'm basically graphing these points here. Once I have plotted those points, all I need to do is take out a straight edge, connect those points with a ruler, and here's my the graph of this linear equation. Let's move on to number 2. So here's 2, same directions as number 1. And I have 6x minus 2y equals negative 10 as my linear equation. What I'm going to do is I'm actually not going to work with that equation. I'm actually going to work with this. And these are equivalent. All I did is I basically solved for y. And you use this, you did something like this on chapter 2. You should be able to get what you see in front of you. If you need clarification, just talk to me in class and I'll be more than happy to do so. But moving on, so I come up with my t-table. The x values that you see there, I am going to compute the corresponding y values. So just like number 1, I plug in x equals negative 2, and I get negative 1 for the y value. When x is equal to negative 1, I get the y value of positive 2. When x is equal to 0, I get 5 for the y value. And as you can see, these are the corresponding y values. I want you to look at something here, and I'll clarify it in class if you don't see it. There's a way that you can get these y values just by looking at this number. Okay, starting from here, you should be able to give me 2, and then 5, and then 8, and then 11. This is a shortcut that you can apply. You cannot apply it all the time, but on some of the problems you can. Okay, so now now that we have the ordered pairs, we're going to plot the points. Here's -2, -1. Here's -1, 2, 0, 5, 1, 8, 2, 11. I don't have room in my graph, so I don't graph it. So I just work with what I have. Draw my line, and this is the answer to number 2. Let's go ahead and move on to number 3. Here's number 3. Y is equal to -2/3 x minus 1. So we're going to use the t-table. Notice that in this case I am not showing you the x values. I'm not going to be using -2, -1, and so forth. I'm going to be using the following x values. And you're going to notice that all these numbers that you see here for the x values are multiples of 3. Why am I using multiples of 3? Because I'm basically going to have to multiply. I'm gonna be dividing by 3. So I want to pick numbers that are divisible by 3. So once I do that, it just makes the process of finding y a little bit easier. So from here, I let x is equal to -6, and negative times negative is positive, and this is just 2. So 2 times 2 is 4. 4 minus 1 is 3. And then when x is equal to -3, again, cancel out. I have negative times negative, which is positive, so it's positive 2 minus 1 is 1. So you see there, when x is equal to 0, it becomes very simple. It's just -1. All this goes away. When x is equal to +3, negative times positive is negative. So this is -2 minus 1, which is -3. And you should be able to see why this is -5. Once I have this, all I need to do is just plot the points. -6, 3. There you see it. -3, 1. 0, -1. 3, -3. 6, -5. I connect these points with a line. And this is the answer to number 3. In a future section, you're going to learn how to do this without using this point plotting method. And you're going to notice that it's going to be a lot easier. But anyway, let's continue on with the next one, number 4. So the direction is a little bit different. It says graph the linear equation by finding its intercepts. They're referring to the x and the y-intercept. So this is a process that you just have to know. To find the x-intercept, what you need to do is you need to set the y value equal to 0. So you go here, and instead of having y, I'm going to plug in 0. All this is going to go away, and you end up with -2x equals 12. Divide both sides by -2. And once you do that, you end up with x is equal to -6. And at this point, you should see that we have the ordered pair -6, 0. Because the x value is -6, the y value is 0. So I go over here and I plot the point. So this is where the graph crosses the x-axis. Now, find the y-intercept. And again, to find the y-intercept, now I'm going to set the x value equal to 0. So this is basically going to go away. I have 4y equals 12. Divide both sides by 4. And once I do that, I get y is equal to 3. So the ordered pair is 0, 3. I graph the point. It's right here. So this is where the graph crosses the y-axis. Once I have those 2 points, I can connect them with the straight line, and I'm done with number 4. Let's go to number 5. Same directions, graphing using the intercepts. So let's go ahead and find the x-intercept. So we set y equal to 0. This is going to go away. You end up with 3x equals 0. Divide both sides by 3 times what number gives me 0, so the x value has to be 0. So I have the ordered pair 0, 0, which is at the origin, and that's what you see here. I'm going to go ahead and find the y-intercept. So I'm going to let the x value equal to 0. And so all this is going to go away. Ask yourself, -2 times what value equals 0? And you get y equals 0. Or you can divide both sides by -2. You get the same answer. And you're going to notice that you end up with the same point as what we found for the x-intercept. So in order for me to draw a line, I need 2 points. And so far, this is representing the same point. So when this happens, what I must do is find another point. So I'm going to let, in this case, x equals 2. Why am I using x equals 2? Because if I plug in 2 here, it gives me a nice number for y. So once I plug in x equals 2, 3 times 2 minus 2y equals 0. This is 6. That's what you see there. Take away, take away 6 from both sides to solve this equation. You end up with -2y equals -3. Excuse me, -2y equals -6. So you divide both sides by -2. Once you do that, you end up with y is equal to +3. So here's the point that I'm going to be using along with the origin, 0, 0. And here's my line. Let's go ahead and go to number 6. Says graph each horizontal or vertical line. So you know that it's either one. It's a horizontal or vertical. On the beginning of this video or the lesson, I explained how you can graph horizontal and vertical lines and the equations of them. But let's say that you forget. So this is a process that you want to have as your backup. Notice that this is saying x equals -3. And when you graph lines, you are basically graphing points. So since x is equal to 3, you're going to come up with 2 points. And guess what? Since x is equal to x is equal to -3, the 2 points, the x value of the points is going to have to be -3. Because it says here x equals -3. You have no choice. Now what about the y values? For the y values, you have choices. Infinite amount of choices. So what y values are you going to choose? You can choose any y values. I'm choosing to work with 1 and 2. So once I have these 2 points, I go ahead and graph them. Here's -3, 1. Here's 3, 2. Once I have the 2 points, I connect them with a line. And guess what? This is a vertical line. For number 7, what you need to do is basically solve for y. I'm going to let you do the algebra there, but you end up with y is equal to 4. You can use a similar process to number 6. Now in this case, you have no choice on what the y values will be. But if you and once you do that, you end up with the horizontal line going through the y value of 4. Or you can use what you saw at the beginning of this lesson, at the beginning of this video, on the first slide, which is there. Whenever you have x equals a real number, it's a vertical line. Whenever you have y equals a real number, it's a horizontal line. And that's what you see here for 6 and 7. This concludes the video. At any point, if you need me to clarify something, just talk to me in class and I'll be more than happy to do so.